Hello everyone, welcome to today's webinar, Performance Testing Management Apps, Avoiding 3 Traps When Testing in Higher Education. My name is Jonathan Bracken, I'm the VP of Marketing here at Neotis. I'm excited to introduce the event today. We're going to hear about some common misconceptions and how our awareness of them can help you be more effective in testing your packaged apps like the ones frequently found in higher education. Joining us today is Dan Downing, Managing Principal from Mentora, and Steve Weisfeld, our consulting lead here at Neotis.
And my name is Dan Downing. I work for a company called Mentora. Mentora is a company that does performance testing. We've been doing this since longer than I can remember. In 2012, we were merged with a much larger IT services company called Foresight Technologies. They're about a $1 billion IT services company out of Chicago that makes us, expands our reach and basically enables us to be in 50 locations around the country. We specialize in performance testing enterprise applications, many of which are used by higher education, and we are a Neotis delivery partner. Steve, let me turn it over to you to introduce yourself and Neotis.
Hey, thanks, Dan. Thanks, everybody, for joining. My name is Steve Weisfeld, as Jonathan mentioned earlier, and I represent Neotis. For those of you that are not familiar with us, we are a software vendor based in the south of France with a U.S. subsidiary based in the greater Boston area. We have a core product, NeoLoad, which is a load and performance testing solution focused on the latest web and mobile applications. As you'll see as we go through the demonstration today, in addition to some of the things specific to PeopleSoft and higher ed applications, we have support for many different technologies with a significant strength in our ease of use and some of the other power that comes along with it. As you can also see from the slide here, significant growth from our customer base, some of you of which are customers of ours already, over the last number of years with just continuation of this growth both in revenue and customers over the last number of years. So Dan, tell us a little bit about packaged apps in higher education and how you've done some testing.
As I started to say, common in higher ed are a number of comprehensive suites that deal with everything from enrollment to financial aid to student records. Probably one of the leaders in that space is PeopleSoft Campus Solutions, but also very well known and around for a long time is a system called Blackboard. In the content creation and delivery management space, there are lots of products and vendors in that space, everything from commercial offerings like Pearson's Open Class, Saba Web Study, but also a number of open source, notably Moodle and Sakai. So if any of you in the audience are in QA and are responsible for testing these suites, you probably either have encountered or are expecting to encounter some idiosyncrasies or special challenges in testing packaged apps that are not developed in-house, and that's what our subject is for today. So to introduce the common traps that we have encountered at Mentora is really three categories. There's probably more, but these are the three most salient ones in my mind. One is complex use cases. Usually because packaged apps are so customizable so that a given institution can make them work with their business flows. The navigation tends to be much more complex. There tends to be a lot of cascading menus as well as optional internally enhanced menus, lots of windows, lots of user clicks. A given business workflow may take lots of windows and lots of clicks. And that's one of the things that, given that it's a third-party application, you don't have the in-house, necessarily the in-house expertise to master the particular use cases that you may be choosing to fix. Even more importantly is test data. Test data tends to be very state sensitive. We can't reuse an enrollment identifier, or student IDs are unique and so forth. There tends to be dependencies across use cases. In the case of PeopleSoft, there are work queues where certain requests are sent to that then individuals assigned to those work queues work off of. So test data tends to be probably one of the biggest issues associated with testing complex apps. Secondly is realistic workloads. It used to be that we talk about e-commerce workloads as how many concurrent users are going to come to your site, or how many page views per second or per minute does your site need to be able to serve. But in the case of enterprise apps, there's much more to it. There's not only active users that are logged into the system and doing something. There's often a lot of users that are logged in but inactive, but still utilizing system resources to maintain their sessions. Moreover, there are completed transactions. Enrollment team may need to be able to close or complete n number of enrollments in a peak hour. These tend to be identified by use case, and in some sense we need to understand what those transaction rates are so as to realistically model the workload. Same thing occurs with concurrent batch processing. Oftentimes not all batch processing is done overnight. Some of it is triggered by interactive workflows, and some of these jobs have to be run during the day, and the question is, what's the impact going to be on interactive usage when those occur? What's the impact on capacity when those occur? Thirdly, we look at the test environment. Oftentimes testing by necessity needs to be done in an environment that's production, smaller than production, different from production. It's essential, we find, in enterprise apps to really test these in the production environment if possible, or an environment that's configured similarly to production, especially including system interfaces, which are critical because it's not just the specific application that you're testing, but all of the systems that interfaces with externally, that also where performance issues can cascade to. We also note that sometimes people ask us to, well, can you test on this smaller environment and then extrapolate to what our performance would be in production? And we find that to be very risky. We discourage that practice. And again, there's nothing that gives you the exact confidence that you need to go live than to be testing on the actual production environment, whether it's after hours or in some cases if it's a pre-production environment that's about to go live. Net, what we've discovered through our experience is that testing vendor software is inherently different than testing software you've developed in-house. You just don't have the same level of control and expertise. To introduce the case study we're going to use here, last year we did a major PeopleSoft upgrade for Capella University. For those of you that have not heard of Capella, they're one of the largest remote learning universities in the country. They're headquartered out of Minneapolis, Minnesota, in that big tower you see in the photograph. They have over 36,000 students in 50 states and 39 countries. They deliver courses and provide accreditations for a number of specific disciplines, as well as many advanced degrees. And they have education alliances with over 500 companies. So this company, Capella, came to us last year and said, we need your help. We're about to undergo a major systems upgrade. We're upgrading from PeopleSoft 8.9 to 2 versions of Campus Solutions and Human Resources. We've got multiple dependent interfaces to the CRM system, to PeopleSoft Financials, to third-party courseware, and so forth. And in addition, we're upgrading our infrastructure because we're looking to increase our capacity, looking at substantial annual growth in our student base and our in-house users. We're planning to. We currently have about 300 concurrent users. We're projecting 500 in 12 months. And the issue here is that we do have a testing team in-house. We've used some in-house tools. I think they were using JMeter at one point to do some localized testing, but we just don't have the expertise to plan and execute a enterprise-wide test like what we're looking to do here. We need some help. So this was the situation that brought us into this project. The approach we used, is, at first blush looks pretty generic. In the discovery phase, we look to identify the high volume interactive and batch processes. We look to specify the workflows and know what choices we're going to make through the various screens. We do the workload modeling. We diagram the environment so we understand what's running where and what exactly are the components in the system under test. In develop, this is where the long pole in the tent is. Those of you that have done performance testing will know that developing automated scripts is a big deal. And but not only that, we also during the develop phase configure all of the servers and appliances in the environment that we're going to monitor resource utilization on. We also take a lot of time to design a test scenario and to generate any stage data we need in the database so that it's available in the right states. And finally, when everything's ready to roll, we test the test. We run shakedown tests to make sure that all of the moving parts that are going to simulate the workload are ready to roll. During the run and fix cycles, that's the iterative part and the fun part here, we run tests while monitoring resources. We expose things in real time. We analyze results after the test. We produce diagnostics that help the tech teams find and fix the problems. And when we think we're ready for the next iteration, we cycle through that again. And at the end of our test, we develop a performance baseline report that the organization can use at the next major change point when they can come back and say, well, let's see, back in 2013, this was our performance signature of the system. These things are changing. Now we can compare against the previous baseline to see if things are better or worse. And while all this may seem fairly straightforward, I think the distinction here is at Mentora we've templatized many of these steps. We have a very clear set of templates for a test plan, a report. We know exactly how to configure monitors and what the salient points are for some of the applications in the higher ed space that we're talking about today. And so we've really, hopefully, we think we've taken this to a higher level, enabling us to either come in and do it for you or come in and help your own testing teams, raise their own PeopleSoft or Blackboard IQ. At Capella, the footprint of PeopleSoft is quite extensive. This diagram, square in the middle, kind of shows it. Each of those boxes is a major application area. And the red squares and the circles inside those squares represent the eventual 14 use cases that we prioritized, eliminating some of the low volume guys that weren't really as important. We identified 9 batch jobs originally. Those were reduced to 3. And then those red arrows indicate the outside system interfaces that we monitored, again, so that we could determine whether performance issues were propagating outward. As an example of TARP number one, I'm catching my own typo there, here's an example of a complex use case. To get to this form where I'm going to update my personal info, if I'm a student or a professor at this school through the community management application, I have to search for myself or for a student ID. I then go to another screen that gives the details. I get the names history if I'm going to add a row to change a middle name, and so forth. And it's multiple windows, lots of clicks just to correct my middle name or make some other biographical change. And each of these times this makes for scripts that are quite complex, and data dependencies that need to be watched very much so. There's different types of users in a systems like this. There's students, there's financial aid people, there's internal enrollment people, and so each use case has a specific security criteria and handles data that is state sensitive. And when you're modeling these kinds of use cases, there's quite a bit more learning that has to be captured in order to make sure you get this right. So to talk about, before I introduce one of the scripts that, to show you one of the scripts that we've done, Steve, why don't you tell us how Neoload handles or assists in building and developing complex scripts?
Thanks, Dan. If you remember, folks, at the beginning of my conversation with you, I mentioned how we have, as part of our customer base, sort of a fanatical devotion for our ease of use concept. And we'll talk about that a little bit. Of course, every vendor tells their tool as easy to use, but what does that really mean in terms of Neoload? And how do we sort of balance ease of use with not loss of productivity or power? Certainly there are plenty of tools that might be really easy to use out there, but don't really do much for you. So, with Neoload, I think we have a significant, well-balanced approach. I think one of the most important things to understand is that our user profile development process is scriptless. So that first bullet that you see here really is a huge productivity gain. So as as Dan talks through the sort of user profiles that he's built for the Capella and PeopleSoft project that he's done, he can certainly talk about how with Neoload, without having to rely on a script-based approach, a script-based tool where you have to have a certain development acumen, or just the fact that it slows you down significantly, it's a huge win using a different approach like we have to offer here. And Neoload allows you to develop user profiles with the most complex use cases, as we'll see in a matter of a couple of slides here. With our user interface, it doesn't really matter what kind of activity you're hoping to model, all done very easily with a series of right-click menus, drop and drag wizards that will make that development significantly more productive. If you remember the slide Dan showed a couple of slides ago, where he sort of dictated the workflow in terms of analysis, design, test, results analysis. The long pole to me of any load testing project is the design work. It's creating those user profiles. So if I can provide a tool for Dan and his team, or any of you out there, that allows you to tighten that cycle up, that's going to allow you to get much more testing done in a shorter amount of time, obviously leading to productivity gains, but also higher quality applications. Neoload, as I mentioned earlier, support for any type of technology that's web-based, including the current incarnation of People tools, as Dan will talk about here. One interesting thing about some of the PeopleSoft applications is they are asynchronous. They do have AJAX activity in there, which is extremely challenging, if not sometimes impossible, to model in traditional script-based load testing tools. In Neoload, it's a snap. We don't care what the technology is, whether we're synchronous, asynchronous. Neoload handles things all much in the same way. We'll also talk later on about our monitoring ability, the idea that we can, in addition to measuring response times from the front end as we're doing a load test against the PeopleSoft application, understand what's going on in the back end. And we have support for all different types of technologies and a very cost-effective approach in our licensing arrangement. Rental licenses, permanent licenses, very flexible, whatever meets the needs of a team like Dan and his, or an end user customer. We can really accommodate any sort of possibility. Dan, if you could move to the next slide just quickly for me, please.
Sure.
I want to just talk about the technologies that we do support. So as you can see, full coverage of all the sort of quote-unquote Web 2.0, I almost want to call it Web 2.1 technologies now. We don't care. The approach that Neoload uses when developing user profiles is the same, regardless of whether you're developing in a simple .NET application up to something much more sophisticated like a ERP or a CRM application like PeopleSoft, all very much handled in the same way. And so if Dan moves to the next slide now very quickly, take a look at what the Neoload UI looks like. And so the left-hand side is our user profile. So nothing up my sleeve, nothing up my magic hat. There's no scripting. And everything that you see here is a representation of the user profiles that you would or a test engineer would develop, all tree view driven, all right-click wizards and so on and so forth, tools that make your development significantly easier. And now, Dan, if you could maybe walk through this specific instance of using Neoload to the PeopleSoft application, talk about some of these pieces and parts that you've and your team have developed.
Sure, thanks, Steve. So folks, you know, in the development phase, you know, when you're wearing your developer hat, one of the important things is to recognize that, especially if you have a team doing a script development, that structured development with good naming conventions and good modularization is key. You can see in that workflow area that Steve was referring to, that the action section, every piece of every major step within the workflow is clearly identified in English, you know, the home page, the sign-in, the menu navigation, and so forth. And it's very easy to add your own, you know, user understandable, business understandable descriptions to those major steps. The other thing we like about Neoload is the way that it kind of leaves breadcrumbs through the workflow. You'll notice that in the middle of the screen there's a partial screenshot of the part of the workflow that we're in when we're entering an address, for instance, and it's shown there, and it kind of provides very nice feedback as to where we are in the workflow. If you need to do advanced things like looping or you know, if then else kinds of logic and you need to insert those into the script, there's a number of ready-made actions blocks that can be dropped into the script. It's a drag and drop approach. You can insert a piece of JavaScript if you need to do something you know, fancier that you know, some computation that is required in order to properly navigate the workflow. It turns out that in the PeopleSoft project that we didn't have to use any of those actions. We simply relied on the visual recorder, and the next page here, the next slide, is on the smart correlation engine that Neoload provides. By default, it will catch an awful lot of the dynamic session parameters that you know, that any application is full of. You know, this is typically where the technical heavy lifting of getting a recorded script to replay correctly is in handling these dynamic values. Neoload will capture those automatically in many cases, not all cases, and where it fails to see one, there's very convenient search functions that enable you to identify, you know, strings that change their value each time you replay, and then there are wizards like the one shown here to enable you to formulate regular expressions to extract them from the return log and replay them forward by inserting a variable and handle it dynamically. So smart correlation is one of the real benefits that enables, you know, that powers the script development, and we find it to be an incredibly productivity enhancing capability. So moving to trap number 2, you know, moving beyond the complex use cases, the next thing I talk about is, you know, how do we get to a realistic work model? I've talked with organizations that say, you know, we've done our performance testing, we model what we think is the workload in production environment. We run our tests and then discover that it really doesn't match what we're seeing in production. So getting to a chart like this, where you have in this case, your 14 workflows, and not just your distribution of concurrent users for each of those workflows, but also how many transactions the business would expect to be able to complete in a peak hour, that second column that's has a red border around it, that is really the fully quantified workload is peak users and peak transactions. Getting to those numbers is another place where you will be challenged, I believe. How do we do it at Mentora? Well, there's different ways to skin this particular cat, but at Capella specifically, they were using a third-party application performance management tool called Coradiant, and we mined the data in that tool to create a URL distribution, which we then sorted from high to low. And that URL distribution we were able to map to the statistics that we got from the business users and the business, the BAs on this project, so that we could really triangulate and get the right target statistics for this, so that we could feel confident that our workload model was going to be accurate. But there's other ways of doing this. There are certainly commercial tools that will do what Coradiant does. Splunk and Dynatrace come to mind. There are also web, free open source tools like Webalizer and AW Stats that you can use on the front tier or on the web tier of the application, and in the hands of a good technical QA person, generate the same kinds of URL distributions that will give you confidence in your workload model. I like to say that Excel is probably the #2 tool that we use in our practice, because as we start to acquire some of these reference numbers, we've got to convert them typically from daily to average hour. Figure out what a peak hour looks like compared to an average hour, apply a factor, look at growth, what is this organization expecting to do in terms of increased volume over the next 12 to 18 months. All of this can be done in Excel and ultimately yields for us a scenario that looks like this. This is just a few of the columns that we would capture in our design templates, where we've got our 14 workflows, our concurrent users, the number of peak transactions we're hoping to accomplish, how much processing time each transaction, and so on and so forth. And I would bore you to tears at this point to try to elucidate this particular model in detail. But ultimately, the point is that we get the data that we need to then move into the Neoload user interface for designing the scenario, and we love the Neoload scenario design piece because it enables us to manage multiple scenarios. We may have a 30% baseline test. We may have had before that a 10% shakedown test. We've got full load tests. So any of these scenarios is independently managed and configured. We can identify what the ramp rates are going to be by a transaction, by use case. We can iterate by time or by number of iterations, so we know how long this test is going to take. And it's really quite a flexible interface. Steve, anything more you want to say about that?
No, I think you covered it quite accurately, Dan.
Great. So moving on. I think, as we lead into trap number 3, which is the systems test environment, why don't you first, Steve, give us a little overview of how Neoload is architected to support complex production environments.
Yeah, absolutely. So if we take a look at the sort of slide here, everyone sort of top down, I guess, for lack of a better way to say, imagine the yellow square on the bottom to be the application under test, regardless of what the application is. Think of it initially as a black box. So what we're doing here with a load testing solution is we're driving load against that black box and understanding how long it takes the load to go from the client, browser, mobile device, whatever that might be, to the application and back, and understanding how that transaction time changes as the load increases. So certainly we can't do load testing manually. It becomes very unproductive to put 100,000 of our closest friends in a cafeteria with laptops. So we use a load testing tool like Neoload. Neoload comes in a couple of different pieces that make up the infrastructure. The very top piece is the controller. That's the environment that the engineers, where Dan and his team will spend their time creating the user profiles, customizing them, running tests, analyzing the results. The screenshots that you've seen of Neoload so far, that's the controller. The load generators are a separate piece. The load generators are the guys that actually generate the load against the application come test time, measure the response times, and then correlate that back into the controller for analysis. Now, as you see in the diagram here, load generators can be in a couple of different places. They can be within your own data center. They can be within a cloud, whether it's your own private cloud or the Neotis cloud. And clouds can be very useful. A cloud approach can be very useful in helping you achieve a more realistic scenario. If you are testing an application that might have real-world users in different locations around the planet, then using load generators scattered geographically around the globe as well would create a much more realistic test. In addition to that level of realism, you'll notice that we have a network emulation device, our simulation as part of our solution, which ultimately allows us to add on top of the network under test realistic network parameters like packet loss, like latency, things of that nature, to give us an additional level of realism. This becomes really important if we are testing applications that have mobile clients, because as we know with our mobile devices, we go from 2 bars to 4 bars to 3 bars, etc., and so we don't always have a great signal strength. So being able to introduce the effects of that change in signal strengths, i.e. things like packet loss and latency, that becomes excessively important towards the realism of creating an accurate load test. The monitoring aspect that you see kind of in the bottom left-hand corner that loops into my yellow box, that is a mechanism that Neoload has that allows me to, while I'm driving load against the front end and measuring response times, understand what's going on in the back end of the infrastructure. And we'll talk about monitoring a little bit more in detail as we go through the next couple of slides, but it is going to be very important to understand what might be the cause of any performance anomalies I determine as part of my load testing. So if I'm running a load test, do some analysis, and understand that, as an example, at 500 concurrent users, all of a sudden my login transaction starts to degrade significantly, that's pretty useful information to the business. But what's more useful is understanding why that is. So by being able to monitor the app server, the web server, the database server, things of that nature, that allows me to much more accurately understand and analyze the behavior of root causes of potential issues. So Dan, take a little, if you could take this architecture diagram, if you will, and show us how you kind of folded it into your test environment when you did the PeopleSoft engagement.
Sure, Steve. Sounds good. So yeah, let's begin with Capella's environment. Not atypical. There was a couple of web servers front-ended by an F5 load balancer, followed up by a couple of actually 2 application servers running the Tuxedo middleware, and in their case they had their database on a Solaris cluster. There was really a total of 5 of each of the middle tiers and 1 database cluster. To this, we bring in the Neoload environment, and now you can see that in the bottom right we've added the controller and a set of injectors in our own private cloud in our hosting facility in Northern Virginia. We've also added a load injector in the Capella environment to simulate local users, and we've also added a resource monitor that we can install the monitoring listener that Steve was just talking about, so that we can securely monitor the servers under test in the PeopleSoft environment. So, you know, similarly, if we needed to expand this beyond what the capacity of our private cloud would be, we can certainly expand this to use Neotis' public cloud. But we can do a very effective simulation of both remote and on-campus users using this configuration, opening up some very convenient ports that don't present a security risk when it comes to being concerned about external hacking.
And I'd add one thing to this, Dan, if I may. I think
Sure.
the idea that you have with kind of the hybrid approach where you've got load generation both locally and remotely, i.e. cloud-based, is very, very advantageous because you can also compare results coming from different locations and get a sense of what the ramifications of the network are. If you can get a sense of what the response times that the local load users are seeing and compare that to the remote users, you can kind of do a delta there and get a sense of network impact on the end real users. I think that is a real key approach to doing a good load testing.
Yeah, yes, exactly, Steve. And Capella was interested in what will students see when they're, coming in from their home or dormitory, wideband network versus what will people that are accessing the internal HR functions see that are locally connected. So that was one of the comparisons we were able to do that way. From the standpoint of monitoring, again, Neoload provides this very flexible monitoring listener that can be stripped off and plugged in right behind the firewall, and there it is right there. And from there, we can monitor all of the operating system as well as system services at a fairly deep level, so that we have visibility into all the moving parts and what the load is impacting, as well as, of course, we're collecting response times and total bandwidth utilization at the controller. And this is especially important. I like to say that if you're load testing without monitoring, it's a little bit like flying without instruments. If the airplane crashes, all you can say is that it crashed. You really can't say why. So monitoring resources and collaborating with the operations folks to provide the necessary access to those devices is critical. One of the things we really like about Neoload, and we've used lots of different tools and still do, but is in the configuring of monitors. First of all, the monitoring is agentless. Nothing has to be installed on the servers under test themselves. And secondly, the wizards that enable or that step you through the configuration actually recommend the most useful counters. There are hundreds of counters, and anybody that is not very proficient in a database or a web server or a Tomcat Java server or what have you, it isn't necessarily obvious what are the bellwether metrics that we should be gathering. Neoload does a very nice job recommending these and their thresholds and their documentation for understanding and configuring monitors is really excellent. So the other thing is the breadth of monitors. Steve, you want to take us through just how broad the application monitors are?
Well, I think you touched on it right there, Dan, and I think this slide is pretty self-explanatory. In a few words, what is inside your application's architecture, and we can basically monitor it. And so you can see that we slice our monitors in a few different categories. We have, operating system level metrics, CPU utilization, memory utilization, things of that nature. And then, of course, things that will be database specific, application, web service specific, thread pooling information, things of that nature. So we, I think, have complete coverage of pretty much what you would find in a web architecture, including the Oracle pieces and the PeopleSoft pieces that make up a PeopleSoft infrastructure. One key thing about us at Neotis, I find that we're always very good about keeping on top of or ahead of the technology curve. So this list continues to evolve as existing servers are updated version-wise, but even as additional technologies are emerging. As an example, with the soon-to-be released version of Neoload 4.2, slightly before Thanksgiving, we'll start to support some additional database servers like Mongo database and so on. And Dan, if you could just quickly to the next slide, just very quick view of how our monitoring solution looks like in terms of either real-time analysis or results analysis. So you can see here lots of different graphs, lots of different views to be able to interrogate or visualize what's going on on the back end while the application is being subjected to the load. And I think a key piece here of our monitoring solution is that this data can be viewed in real time while a test is being executed, but also post-test. So when you want to do your analysis with other team members or whatever your organization sort of works for in terms of analysis, you can always create post-results graphs and slice and dice data to make your analysis much more productive. Dan, talk about some of these specific graphs that you're showing here and how they came out of the PeopleSoft
Yes,
testing.
absolutely, Steve. And in fact, you know, another one of my pet phrases is in the results analysis that a performance tester really earns their stripes. It's no value to simply run a test, push the button that says generate standard report, and send that out to your stakeholders and expect them to make sense out of this. It's really through a interactive graphical interface like the kind that Neoload provides that enables the slicing and dicing, the overlaying of different metrics on the same graph to visually correlate, the looking at response times versus resources versus load. And this is the kind of thing that you're seeing here in this UI. To get more specific about the Capella examples, you know, we saw some very interesting things as we're generating load that we weren't necessarily able to explain right away. So here's an example of a graph that shows some of the slowest transactions as load increases and stabilizes at 350 users, I think was this test. You'll see that we have some very large spikes to up to 8 seconds and higher, and they seem to be clustered every 5 to 8 seconds, and we really couldn't figure out what was going on. As we looked deeper, we discovered that the virtual memory of several of the VMs were undersized. And as we increased the VM memory to 12 gigabytes on I believe this was on the app servers specifically, we saw that those spikes still you know, hit some high marks, but only in the ramp-up phase. And then as we got into the you know, higher, you know, as we reached maximum load, they settled down to under a couple of seconds. So that was a substantial find and fix that the graphical analysis enabled us to hone in on. Another example is this is a graph of CPU idle time on the 5 app servers. Each of those colored spiky lines is an app server, and you can see that the standard, you know, kind of the average utilization is around, you know, 10 to 15%. That's where the spikes are clustered. But that occasionally you'll see some spikes, you know, at minute 26 they're down to 85%, even though it's a short duration. So we saw, you know, we were concerned about these regular spikes that seem to be repetitive again. And what by looking more deeply in association with the Capella technical teams, we were able to identify some repeated cache refreshing database queries that seem to be soaking up a lot of resources. Once we fixed that problem, those spikes were reduced substantially. And here's a second graph where we also indicated the times that we launched certain batch processes that were known to be high resource consuming to gauge what further impact those might have on resource utilization and on response time. So again, just a very quick snapshot of the power of the Neoload analysis tool, analysis user interface, and kind of the methodology that we employ here and honing in on where the trouble spots are. So moving to Capella outcomes specifically, there were some significant things that we found and fixed. Here are 3 of them. There were virtual memory adjustments, there was swap space adjustments, all happen to be associated with you know, moving from Solaris zones to VMware and some configurations that were not optimized. We also identified several caching algorithms that needed to be refreshed that that substantially reduced the impact on the database and improved performance time. And then there were systems interfaces that were poorly configured that fed out consuming systems on the outer sphere of PeopleSoft, and we were able to identify configuration issues there and get those optimized. So, at the end of the day, why do we performance test? Well, to find problems and fix them before we go live. At the end of this project, the organization achieved confidence to go live. They did go live last fall with no problems. The teams that work with us increased their PeopleSoft performance IQ substantially, and it was viewed by the IT director, Tracy Smith, as a very cost-effective and collaborative effort. If you want to hear this in Tracy's own words, please email us to info@mentora.com. We'll send you the link to where this audio portion is, so you can hear from the stakeholder herself directly. So, in conclusion, the three traps that we've identified in performance testing third-party packaged apps, in the case of complex use cases, we really rely heavily on subject matter experts, on the BAs in the organization to learn the navigations, to learn the data state sensitivities, to really understand how use cases depend on each other for states of data. And we very carefully annotate screenshots and diagram data flows and define data needs. This is part of the discovery step, and without understanding this correctly, you will encounter lots of challenges in getting scripts that are time-consuming to develop and harden and replay consistently to work if you've left out taking some shortcuts in understanding the use cases. In case of the realistic workload modeling, again, we sort of triangulate between data that we ask the organization to provide, the business users that know how many enrollments in a peak hour should be able to be completed. We also triangulate against statistics that we pull from the production environment to make sure that our workload model is accurate. And finally, testing on the production environment, we can't say how important that is. That isn't always possible, although in many cases, big upgrades like what Capella went through are coupled with configuration refreshes, environment refreshes. And in those cases, you're testing on the pre-prod environment, and it's really pretty easy to say, yes, we tested on prod just before it went live. And this is clearly the best of all worlds. But if you can't do that, you should at least have a copy of recent production database and an environment that is very production-like, including whatever systems interfaces are involved. And definitely recommend against attempting to extrapolate results. That is a very risky proposition. So on that note, Jonathan, why don't you take it away and see if we've got any questions that we can answer.
Great, thanks guys. A great discussion, and certainly appreciate all the insights there. For those of you who have questions, there's a number of folks who have actually posted some already, but just a reminder, go ahead and you can type it into the questions widget inside the GoToWebinar panel, and we'll get to as many as we can. We can go a few minutes past the hour just due to the late start. But that said, let's get to it. First question, could you have used open source tools like JMeter to performance test PeopleSoft?
That's a great question. As a matter of fact, Capella did have some JMeter expertise in-house, and they had, Jonathan, done some spot testing with JMeter on a modular basis. Let's call it component level testing. What they discovered is that to handle a system as broad and complex as the modules of campus solutions that they were deploying, that JMeter just didn't cut it. It had limitations in terms of numbers of users it could simulate. You had to sort of jump through hoops to overcome some of those memory management issues. The development of scripts was more time-consuming. Certainly possible given enough time, but you know, the user interface for analyzing results is much more primitive. You're pretty much relegated to pumping CSV files into Excel and doing your analysis in Excel. So it's certainly doable, but the trade-offs are you lose the robustness and the ease of use of Neoload script development, robust monitoring, and very capable analysis capabilities.
Thanks, Dan. Many of our users use the PeopleSoft Campus mobile solution. Can we include that as part of our load testing?
Yeah, I can take that, and from a Neoload perspective, absolutely. And I think that's one of the things that's unique to Neoload is ultimately we are not concerned with what the client is. It could be a desktop browser that the users are accessing the application through, or it could be a mobile device. Now, mobile devices present some interesting challenges to load and performance testing tools, and that is how do you ultimately record the activity coming from a mobile device from your Neoload or from any load testing tool on a desktop. So with Neoload, we have a number of different options that allow us to capture any activity, whether it's coming from a browser-based application on a mobile device or a pure native application. We don't care. So complete coverage. Any kind of applications client, doesn't matter where it is, we can include that as part of our user profile development. And then in terms of actually replaying our load tests, if you recall, I spoke a little bit about the network emulation piece, and that's a key piece of load testing and including or accounting for users interacting with your app through mobile devices, being able to not only make sure you're generating the right kind of activity traffic, but also the right kind of bandwidth. So by being able to add the network parameters to simulate a 4G LTE or a 3G line is an extremely important part of that. Very easily done with Neoload.
Thanks. Next question is, did the higher education environment present specific challenges that are different than private sector?
Okay, well, I'll take that one initially. In some sense, generically, no. I would say that packaged apps, whether you're using Oracle ERP or testing PeopleSoft Campus solutions, the same challenges arise from a testing perspective. What does arise differently in higher ed versus private sector is the culture of the organization. We were very pleased at PeopleSoft to have very committed and very savvy tech teams to work with, as well as BAs to consult with. So their internal culture was very results oriented. There was not the usual barriers that you encounter when you're crossing between testing and operations, and this applies to to private sector as well. But I would say that what you're going to experience is context specific. What's the culture of the higher ed university that you're associated with to getting things done and to applying the necessary resources and committed to actionable results and committed to quality. Those are the questions I would ask that would surface any major differences.
Thanks, Dan. There's a few questions that are all around the same sort of theme, so I'll see if I can combine them. Essentially, it's how long should you plan for performance testing a campus solutions upgrade, and specifically, how long did Mentora spend on the Capella project from start to finish?
Yeah, great question, and we get that one often in lots of context, Jonathan. So, I'd like to say that when you're testing a enterprise-wide solution like PeopleSoft Campus Solutions, plan on 3 months, end to end, and that includes the kind of the run-up to understanding how we're going to engage. The discovery phase is usually accelerated and accomplished with a week on site of our team. Typically, our team will consist of 3 or 4 engineers that will slice up the subject matter experts and the applications and use cases into discipline groups, so that somebody can be focused on financial aid while somebody else is focused on enrollment, since there's different nomenclatures and different considerations. But discovery, if it's well organized up front, kind of with the preamble meetings, we arrive on site, we do that in about a week. The development phase typically is a 4-week process, 4 to 5 week process, depending on the scope of how many workflows there are, how many interfaces there are, how many batch processes have to be folded into the load scenario. And then we get to the test execution, and that typically, while it's not an 8 hours a day, 7 days a week kind of thing, will span 4 to 6 weeks to do 3 or 4 or 5 test cycles. I believe at Capella we ended up doing 5 test cycles, but they were several days apart, as we giving us time to analyze results, review them with stakeholders, make the appropriate fixes, regroup, and schedule the next test. So that last phase of run, diagnose, and fix will typically span a calendar month or more, again, depending on the number of tests it takes to solve all the problems. And finally, the last phase of reporting, once all the hard work's been done, then generating a baseline report is a matter of a couple of days, and then getting together with stakeholders to present that.
Okay, thanks. This one is pretty specific to Neoload. I can actually take part of it, and maybe Steve, you can help with a piece of it. Do you have a demo version and user manual, any recorded demo of scripting using Neoload, and what is the dynamic data handling mechanism? For the first 2 parts there, yes, there's a trial version of Neoload that's available on the neotis.com website. And there's also a resource center that has a number of demos that will show how to do various aspects related to the product, including a feature tour. There's also a weekly webinar that people can attend. But in terms of the last piece of it, what is the dynamic data handling mechanism? Maybe Steve, you could take that one.
I think the answer really is just kind of what you said. I think the best way to explain it is to take a look at the trial and walk through the demos and try yourself, because there's a number of different approaches depending upon what it is you're trying to do and what your actual situation is. So I think much easier to answer the question by showing. So for the person that did ask the question, take a look at Neoload, get your hands on it, kick the tires a little bit, and then come back to us with that question. We can maybe do a specific webinar or remote session where we can walk you through the actual techniques with your application against Neoload.
Okay. Thanks, Steve. Now, I think let's just take one final question. I know we're a few minutes past the hour. Although we've got some other questions, we'll try to get back to folks separately offline. But this one's kind of a fun one, and it's certainly very topical. Based on best practices you've demonstrated, if you could theorize, in light of the healthcare.gov performance issues, what techniques would you suspect were not done correctly that led to those glitches?
That's a good one, and very topical and very timely. I'll take a stab at that one, John. So, as a matter of fact, friends came over for dinner, the night after the initial launch of the healthcare.gov website, and they all said, "Oh, the reason they had those problems is they didn't hire you, Dan, to go test them." And that's obviously tongue-in-cheek, but fundamentally, from what I know about the healthcare.gov environments, is that what the 2 major issues that come to bear that relate slightly to, on a very microscopic scale, to the Capella project, and that is that the health.gov system has to interface with something like 35 states' databases and systems to pull data from those disparate systems and databases. in real time in order to be able to actually generate, or submit your, compose a request to sign up for healthcare. And that basically, that external dependency is huge, and clearly not enough time was available to properly test. I mean, that's the only thing one can say, is that there was an awful lot of testing that got squeezed out at the last minute. The other thing that I heard about the health.gov is at the very last minute there's a requirement change where you had to actually log in before you could begin the dialogue interacting with the resources. And that login process typically is, in any system, is an expensive process and slows things down. And when you get an onslaught of people logging in, you're definitely going to have to account for that. And there's lots of different ways of accounting for that in a system that's going to be heavily used like this. There's this notion of waiting rooms that, you sort of take a number and then your number ticks down, and at least you know that you're in the queue and something's happening, as opposed to system not responding. But, I suspect that, shifting requirements, external interfaces, and simply not enough time to do all the necessary testing were at issue in the case of healthcare.gov.
Yeah, I think that's exactly right. I'm intrigued too, and I think the change in the specs sort of at the quote-unquote last minute is potentially a big piece of it. I mean, I have no idea what was done for load testing and/or what sort of tools they use, but if they were using a legacy vendor that it takes a long time to do stuff with, and if you had a last-minute change in requirements, that obviously just didn't meet their timeline. One thing that's pretty sort of interesting is, and so just as an anecdote, there's been a lot of email conversations about this specific instance within our team here at Neotis, and there's an article today, which some of you may have seen in USA Today, talking about the recent hearing around this. So I'm going to read just a quote that I was looking up very quickly as Dan was just talking. It just, I think, talks to the problem. Now, as more and more users have been able to proceed to the exchange over the past several days, more individuals have enrolled in qualified insurance plans, the official's testimony says. However, the increased number of transactions in the exchange have caused system performance issues, such as slow response times or data assurance issues, that now need to be addressed through tuning, optimization, and application improvements. Right? I mean, it says it right there. Didn't test it right.
Great.
Yep. Go ahead, Jonathan.
No, I was just going to wrap up, Dan, but if you've got any final thoughts, please go ahead.
Yeah, no, but just to sort of wrap up that question, which is a very good one, is, what are the best practices that were not followed here? Unfortunately, if performance testing is not planned for from the very get-go, and it is not introduced at the right points in time, which is typically after functional testing is complete and user acceptance testing is complete, and the system is deemed operational, then you need a couple of months to really, you need at least, for a system like health.gov, I don't know, maybe you need 3 months or more. And if that time has been squeezed out of the plan, that is going to be a problem. And I certainly recommend any of you engaged in performance tests in your organizations to sort of be very clear with your stakeholders on what can be done given the constraints of a project.
Great. Thank you, Dan. Thank you, Steve, and especially thank you to the audience for those of you who stayed late to hear some of the answers to these questions. Certainly appreciate all of your attendance. If you do want additional information, please visit the Mentora website, www.mentora.com, and or the Neotis website, www.neotis.com. And certainly you can feel free to reach out and contact us at the information you'll see on your screen. Thanks very much.